I'm Catherine Burley. I'm a PhD student in public policy at UNC, and today I'll be talking about my ongoing project, Restoration Equity. As climate change continues to contribute to more extreme weather, power outages are becoming more frequent. Typically, we use reliability metrics like SAIDI or SAIFI to tell us about the duration and frequency of outages that the average customer experiences. But it's also important to understand how people within a utility territory or affected area might experience power outages differently. There is evidence that the negative health and social impacts of power outages are disproportionately worse for certain groups, like people of color, low-income households, and people over 65. There is also some evidence that low-income households and people of color experience longer outages, which could exacerbate these negative effects of power outages for these groups. However, this evidence is mostly based on limited cases of really extreme events, such as Hurricane Maria in Puerto Rico and the 2021 Texas winter storm. Part of the reason why there is limited evidence on this topic is due to the lack of publicly available historic data on power outages that could be used to assess this question. This project has two goals. First, to assess power outage duration after severe weather events in the Southeast at the census tract level using nighttime lights, and second, to investigate the relationship between neighborhood demographics and outage duration. Using the results of this analysis, I will develop a measure of restoration equity to complement existing reliability metrics and characterize how power outages are distributed across an affected population. Nighttime lights data are a form of remote sensing data that provides measurements of visible light from Earth, and they have been used to study a number of topics, including access to electricity and disaster recovery. Specifically, I'm using NASA Black Marble daily adjusted nighttime lights data. This data set is great because much of the processing and correction has already been done by NASA. It's also publicly available and consistently reported, which might allow for a more systematic assessment of outages across events. However, cloud contamination in daily data can be a major issue, especially since severe weather may linger over an area for multiple days. It also only allows us to look at multi-day outage events, since we only get a single snapshot of each day. This project is still ongoing, but I'll talk a little bit about what I've found so far. First, there are limitations to measuring outage duration using nighttime lights. So far, I've considered 10 multi-day outage events between 2018 and 2022. Before I look at census tract level, I identify the counties that experience prolonged outages during each storm as a validation check. Only 3 of these 10 events have sufficient data for neighborhood level analysis due to missing observations in the week after an event occurred. All of these 3 events are hurricanes, so these are quite severe events. When the data is sufficient, nighttime lights data performs well at identifying outages and recovery. This is showing county-level outages for Hurricane Ian a week after the storm, and the restoration patterns align well with data from other sources. Even though I'm not able to assess all events, the nighttime lights data does enable comparison across events that have good data coverage. For these 3 events, I estimated outage duration at the census tract level, and I am currently evaluating the relationship between outage duration, demographics, and other factors typically associated with power restoration, such as weather severity, utility restoration protocols, and things like remoteness from urban areas. Our measure of outage duration is the net number of days without electricity estimated from nighttime lights. So a coefficient estimate greater than 0 indicates a longer outage, while less than 0 would indicate a shorter outage. The demographic index here comes from EPA's EJ screen, and it is the average of the percentage of people of color in low-income households in a census tract. In the first set of coefficients, we can see that the relationship between outage duration and demographics is insignificant or even negative. This would suggest that in these storms, census tracts with more low-income residents and people of color are not experiencing longer outages than wider, higher-income census tracts, and may even have shorter outages, like in the case of Hurricane Ian. Although this is just a simple correlation, it's still important because this most closely reflects the overall experience of different census tracts after a storm, before accounting for other factors. But this might not tell the full story. The other 3 sets of coefficients show how the relationship between demographics and outages shift up as we account for other factors, particularly for storm severity and restoration protocols. When we talk about the equity in power restoration, it's key to understand how these other factors might bias the relationship between demographics and restoration. So something like storm severity might seem random, but when we look at the demographic index by census tract for each event, we actually see that areas along the coastline tend to be wider and higher income, and also tend to be exposed to more severe weather, which might be obscuring an underlying relationship between outages and demographics. As I wrap up this project, I'm still teasing out these relationships and how to incorporate them into the final restoration equity metric. If anyone wants to hear more about what I've done or discuss my findings, please reach out. I'd love to chat. Thank you.